So today we're going to talk about section 1.2, and 1.2 is on relationships between angles. Okay, so we're going to see some situations where we're going to be comparing angles, seeing if they're the same size, or if they together make another angle or something like that. So that's where we're going to start today. And in that we're going to talk about parallel lines because there's some interesting relationships between angles when there's a parallel line situation. So let's start with that. So let's draw a set of parallel lines. Okay, they don't have to be horizontal or anything like that, but any set of parallel lines. Parallel just means they don't intersect. Okay, and then with these two parallel lines, I'm going to cut them with a third line that we're going to call a transversal. Okay, it transverses both of the parallel lines or crosses them. Okay, so we have the transversal, and we have two parallel lines. Okay, now excuse me. Now in this diagram, you can see many angles forming. In fact, there are 8 angles. There are 4 where the transversal and the top parallel line cross, and there are 4 more angles where the transversal and the bottom parallel line cross. Okay, and so I'm going to number those angles. We're going to number them 1, 2, 3, 4 up on top, and then 5, 6, 7, and 8 on the bottom. Okay, so what we're going to find out is that there's some relationships between these angles. Let me first give you some names for these angles. We've got what we call interior angles. The interior angles are the angles between the two parallel lines. Okay, so those are the angles 3, 4, 5, and 6. Okay, so 3, 4, 5, and 6. Those are the interior angles. The exterior angles are the ones on the outside of those parallel lines. Okay, so that'd be 1, 2, 7, and 8. There's other types of angles as well. We have the alternate angles. Alternate just means they're on alternate sides of the transversal. So like 1 and 2 are alternate, 1 and 6 are alternate. Okay, so if they're on each side of the transversal, they're alternate angles. Corresponding angles. Okay, so I'm just going to, rather than write them all up here, I'm just going to give you some description verbally. Corresponding angles are angles in the same position on each parallel line. So for instance, angles 2 and 6 are corresponding angles, and angles 1 and 5 are corresponding angles. Okay. Also vertical angles. Vertical angles are angles opposite each other on the same intersection. So something like 6 and 7, those are vertical angles, as are 1 and 4. Okay, they're opposite each other at the same intersection point. Okay, so that gives us just a few definitions. What's interesting is there are certain relationships between these angles where we know they're the same size. And in fact, anytime you have two angles that have the same size or the same measure, we call them congruent. Okay, so congruent angles have the same measure. When we say have the same measure, that just means they're the same number of degrees. Okay, so two 30-degree angles are congruent to each other, for instance. Okay, so in this case, and the symbol for congruency, it looks like an equal sign with a little squiggle on top. Okay, So we're going to use that symbol for congruency. Okay. And one other thing along those lines, if you know that two angles are congruent, let's say angle A is congruent to angle B. Now I don't have A and B up in this diagram, I'm just giving you some notation. If you knew that two angles were congruent to each other, that really just means that their measures are the same. And so we would say the measure of angle A is equal to the measure of angle B. And that's what that M means, is the measure, okay? So this is just notation. These two statements are essentially interchangeable. Two angles are congruent, meaning their measures are equal, okay? Okay, so for our discussion, I'll just go ahead and stick with the congruency relationship. And so what's interesting about this parallel line situation is that vertical angles are always congruent. Now that doesn't matter, not just in this situation, but in all angles, okay? So vertical angles are always congruent. Okay, they're always congruent. Doesn't matter where they are. If there are two lines that intersect at a point, then the vertical angles are always congruent to each other. Okay, and it doesn't matter which vertical angles, they're all going to be congruent. Okay, and so that's the case on this. And so we can list 4 sets of congruent angles by their vertical angles. So 1 and 4 are congruent, 2 and 3 are congruent, 5 and 8 are congruent, 6 and 7 are congruent. So we have all those combinations. I could write them all out. Angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3, and so on. The other 2 you could write out if you wanted. Okay. All right, so that's the vertical angles. We also have a theorem, and I'm not going to go through and prove all of these. There are proofs for them. You may have seen if you took a geometry course, say in high school or something. But so there are proofs of these. We're just kind of going through and reviewing these ideas because we're going to use them later. Okay. So the next one is that alternate interior angles are congruent. Okay, so let's look at alternate interior angles. Okay, they're always congruent. And so an example of alternate interior, if you think about the interior angles are of course 3, 4, 5, and 6. The alternate angles are angles on either side of the transversal. And so if you think about alternate interior angles, those would be angles 3 and 6 because they're interior and they're on either side of the transversal. And also angles 4 and 5, okay? So angles 3 and 6 are congruent, angles 4 and 5 are congruent. And you can kind of see that just the way that I drew this out, it appears that angle 6 is less than 90 degrees and angle 3 is less than 90 degrees, and they kind of look the same, but they can be proven to be the same. Okay, so angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. So those two combinations are going to be true. Okay. Let's get rid of some of this. All right, let's look at another one, alternate exterior angle. So instead of looking at the inside, let's look at the outside. Alternate exterior they're also going to be congruent. Okay, so alternate exterior angles, that would be like 1 and 8. They're alternate different sides of the transversal and the exterior. Okay, so angle 1 is congruent to angle 8. And let's see, angle 2 and 7 would then also be congruent. So angle 2 is congruent to angle 7. All right, so we have those two relationships. We also know that corresponding angles are congruent. Okay, so let's take a look at what that means. Corresponding angles are congruent. So corresponding angles, we said, are angles that are in the same position relative to each parallel line. So angles 1 and 5, they're going to be congruent. Okay, so angle 1 is congruent to angle 5. 2 and 6, angle 2 is congruent to angle 6. 3 and 7 and 4 and 8. Okay, so angle 3 with angle 7 and angle 4 congruent with angle 8. So we get those 4 relationships there. I've already talked about the vertical angles. So it's 1 and 4, 2 and 3, and so forth. And then we have the angles on the interior angles on the same side of the transversal. So it'd be like 3 and 5 and 4 and 6. Those are not equal. They're not congruent to each other. What they are is supplementary. So I've got a couple definitions I got to give you now. Now that I use that word, supplementary angles and complementary angles. Okay. In fact, let's do the complementary first, and then we'll talk about. So let's see. Complementary angles add up to 90 degrees. I think we mentioned this in the last section, actually. This was part of section 1.1. And then supplementary angles add up to 180 degrees. And so when we look at the interior angles that are on the same side of the transversal, they're going to be supplementary. Okay, so angle 4, I'm sorry, the measure of angle 4 plus the measure of angle 6 will equal 180 because they are supplementary. And same with 3 and 5. So measure of angle 3, measure of angle 5 will add up to 180 as well. And you could do the same thing with the exterior angles on the same side. So you could do 2 and 8, 1 and 7. Those are also going to be supplementary angles. Okay, so